There are lots of different keywords in Java, and up until now, we've been using some that maybe we didn't actually know what they did. One of those is the static keyword. When we were writing client classes, or classes that have main methods in it, the word static was everywhere. It was in front of class constants, it was in the main method header, and it was in front of the header of every method we wrote within one of those types of classes. And then we started writing objects, and suddenly that static keyword disappeared. So what does static really mean? When you make a code element static, what you're saying is this element belongs to a class, not an object. And what that really means is something that's static, there's only one of that in any given code run, meaning it can't be instantiated in multiple different versions. Let's look at the definition of an object. Now we have a combination of static and non-static fields, static and non-static methods. In the object definition, we can have as many of these things as we want, but then when we look at the instances of the object, meaning something created by the keyword new, they don't have those static things inherited. That's because those variables and methods that were created in the class definition only live there. So there's only one of them across however many instances there are. Let's look closely at static fields. These are declared and their value is stored in the class definition instead of in each specific instance. So what this means is you have a variable with one particular value that is shared across all instances of an object who can both access it and modify it. But if one instance changes it, that change is going to be represented across all instances. Because there's only one of these values, actually external code you can expose it to external code with the public keyword by the name of the class dot the name of your static field. Here's a good example of why you would want a static field. Let's say you have a field called object count. You set it to 0 and you make it static. Then in the constructor, you increment it. This means that anytime you create a new instance of this object, the variable object count is going to go up by 1. So you always know exactly how many instances of your object are currently in existence. You can also have static methods. And again, they're declared in the class and not used in the individual objects. All the objects can see it and they can use it, but they don't have their own copy of it. Static methods are really limited in what they can do, and that's because they do not have the implicit parameter this. They have no concept of an individual object instance. What this means is that they can't access any specific fields, so they can't do anything inside of them that are specific to the state of the object. So why would you want a static method? Well, a lot of times you use it in combination with a static field. For example, if we make our static field private, but we want people to still be able to see the value inside of it, we can make a static method that just returns that value. Now everybody can still get that value, and maybe I want to add some limitations for encapsulation purposes into the static method. Overall, you're going to want to be very frugal with how you use static, because it can be a little tricky since you've got this thing that there's only one of, and then everything else you want to make sure that you can have infinite versions of for each individual instance of your object. But it's an important part of knowing what's going on across your objects, so it's a good thing to practice on your journey to becoming a software developer.